forgot to hit record last class, so hopefully I'll capture it this time. Okay, so I'm going to move over to this slide over here. And we're going to take a look at recursion because it's going to drive something else home. We know that we write programs, okay? And when a program is executed, of course, it's loaded into memory, it becomes a process, it becomes an active or a dynamic entity. So it gets resources like memory, the CPU, network connections, whatever else it needs. But what I haven't introduced yet is not only is a program, when it becomes a process, does it get memory, but the operating system actually has to perform some management here because it actually needs to have 3 different types of allocated memory. When a process is created, the operating system provides it with a data segment, a code segment, and a stack segment. Now, of course, the code is the code, the executable code, okay? And again, it's relocatable, and I won't go back into that. Data, of course, is the variables, especially the global variables, okay? So if I had, say, up in my public static void main here, if I had int x, that x would get space allocated for it in the data segment. So there's my code and my data. That leaves the stack. Okay. There is no way to know before execution how a program will run or what will be required. There will be procedures there or methods that may be called many times, may never be called. Okay? So it doesn't make sense to reserve space in a data segment for them. Because if I followed that model, I'd have to predetermine, okay, you can call this method 10 times, but that's it. Because that's all the space I'm setting aside for you. And of course, if you never call it, you're wasting a lot of space, wasting a lot of memory that the system could use otherwise. So we need some other mechanism to handle procedure calls or methods. And the stack is what the system uses. Now, what is the stack? The stack is a last in, first out data structure, LIFO. Okay? Think about a stack of quarters. If I start stacking quarters, okay, 10, 11, 12, and then I want to take one off, which one am I taking off? The one at the top. It's called popping the stack, okay? So the first one out is the last one I put in. It's a stack. It grows upwards from low to high, okay? You've probably seen Windows Stack Overflows or other types of messages, okay? Now, this is in contrast to, say, a queue, okay, which you'd see at, say, a movie theater. Movie theater, you get in line. Who do they serve first? You. Who do they serve second? The second person in line, okay? First in, first out, FIFO. So here's kind of a introduction into programming logic 2 with data structures, okay? LIFO and FIFO. Many other things, trees, things like this nature, we won't get into. So, again, a process will have a data segment, a code segment, and a stack segment. Now, I have an example here because it's really going to drive home the stack component here. Okay, and what it is a recursive decimal to binary. Okay, so let's just kind of get in the mindset again. How do we? And here the example. Of course, I'm calling print binary 13, so I'm actually going to do it with 13 over here. How do I convert decimal 13 to binary? Well, of course, humans, again, we're information specialists. The easiest way is by just observation. I don't even need to write the powers of 2s there. But I did, so I wrote the table, the 1s, the 2s, the 4s, the 8s, and of course that's the 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and so forth. And by observation, I just, 8 will go into 13 once. 13 minus 8 is 5. Okay, 4 will go into 5 once. Okay, 5 minus 4 is 1. So, of course, 2 will not go into 1, and, of course, 1 will go into 1. So there it is, 1, 1, 0, 1. Okay, or I could put 0b in front of it to indicate it's binary. Okay, now this is not efficient, of course, for a computer because I could give some arbitrarily, 1,026,000. What would the computer have to do? First, it would have to find the highest power of 2, its largest common denominator, and then work backwards. You know, a computer, of course, you could write that program. It wouldn't be the most efficient. A computer, we could use iteration, a loop. Okay, so let's take a look at this. Okay, I could use division. Okay, and divide 13 by 2. Okay, 13 is the dividend, 2 is the divisor, and 13 divided by 2 is 6 with a remainder of 1. And I'd save this, and then I'd reuse the quotient 6. Okay, which would become the new dividend. 6 divided by 2 is 3 with a remainder of 0. Okay, again, take the 3, the quotient, and make it the new dividend. Okay, 3 divided by 2 is 1 with a remainder of 1, and so forth. Okay, and we could code this very easily. Okay, I could create a loop, you know, dividend divisor. I could put it into a procedure, okay, and do it that way. But if we look at this, okay, let's look at our result here, 1101, whereas our result here is 1011. It's backwards, okay? And obviously I couldn't just print out the remainder, right, because I moved left to right. If I just printed this out as I got the remainders, it would be 1011, and again, it would be backwards. So a few things I could do here. One, I could use an array, right? I could store this in an array, okay? So an array position 0, 0-based addressing would have 1. Array index 1 would be 0. Array index 2 would be 1. Array index 3 would be 1. I'd maintain a counter. You know, what is my max array? 3. And then I'd print it out from 3 down to 0. So I'd print the array in backwards order, 1101. Okay, I could do this, okay? And truthfully, doing it this way would be just as efficient as the recurrence I'm about to show you. But then I wouldn't get to show you recurrence either. So, so just to increase everyone's pain here. Okay, so here we go. Let's take a look. Of course, just the syntax, public class, simple decimal to binary. Okay, public static void main. You guys know this by heart, you know. System.out.println. And here it is. Print binary, of course, which is a method call. And here's the definition of print binary. And I'm calling it with the argument 13. Remember, arguments are actual, whereas down here, I have a parameter. Dividend of type int, okay? So, in looking at this, if dividend is greater than 0, return, it's going to return, but here's another call to print binary. A call to print binary from within print binary. Okay? This is recursion. Okay? And then the plus, and here, since it's in a print, I'm using plus here, and this is going to be a string at first. Of course, the plus operator is overloaded, so it's actually just going to concatenate these things. Okay? So you can actually see where I'm going here is because I'm going to kind of do this backwards, whereas recursion, what we do is we often decompose a problem down to its elemental components and then work backwards. So we're actually going to trace through here. I have some things written out just from last class, and in between these lines here are essentially what I'm doing is depicting my stack. Okay? Now here I said a stack goes from the bottom to the top, but it kind of makes sense here. I just did it in line, so this stack is actually growing from the top to the bottom. So let's go through this. Here we go. System.out, println, print binary 13. So I have the 13 is my argument, okay? And the entry point is here. Print binary int dividend. What happens with a method invocation here is the argument will become instantiated as the parameter. So I have, first time through, d equals 13, okay? So here I am. If dividend is greater, so really, these are here kind of in advance, okay? If I was really doing this, okay? So maybe I will do this. Give me a couple backspaces here just because I don't want to confuse anyone. Okay. I'll leave these other things here. So, but here's where I am. D equals 13, and I start executing. If dividend is greater than 0, is dividend greater than 0? 13 greater than 0? Yes. Okay. So return, and note, I can't return until I do everything within the parentheses, right? So the first thing I'm doing is print binary dividend divided by 2. So automatically, and I don't do this yet, I call print binary, and this time I'm passing it the argument 13 divided by 2. Oh, try the other paren. 6. And there we go. And at this point, execution jumps entry point. Print binary, dividend, okay? Dividend got what was just passed in. The argument 6 becomes dividend. If dividend is greater than 0, is 6 greater than 0? Yes. Return, here's another method call. Print binary, dividend divided by 2. Dividend divided by 2, 6 divided by 2 is 3. Okay, great. So I call it with 3. Again, I'm back here, entry point. Print binary, okay, dividend, okay, copy that 3 in, so there we are. If dividend is greater than 0, 3 is greater than 0, yes. Return, print binary, dividend divided by 2. Okay. And again, execution now continues at the entry point. Print binary, int dividend, what was passed in, the 1. If dividend is greater than 0, it is. Return, print binary, dividend divided by 2. Dividend 1 divided by 2, 0. Okay, jumps to print binary. So note, all of these are instantiations of print binary that have yet to complete. I have yet to complete a single print binary. I have a print binary inside a print binary, inside another print binary, inside another print binary. Okay, so here's my stack, and here's the system keeping track of it. So in this last case, I called it with 0. So dividend equals 0. Okay. If dividend is greater than 0, 0 greater than 0? No. So here's my stopping case. I'm not going to call print binary. I'm going to return the empty string, wherever my open quotes are. How about a single quote? Oh, there they are. Okay. So I'm returning that. Okay. So now this has completed. The last time through is completed, which means it would be popped off the stack, and I would be here. Recall the last thing I did here. Okay. I have print binary, which just returned, what did it return? The empty string, so I have the double quotes, plus dividend mod 2. So I now am appending double quotes plus 1 mod 2, of course the remainder is 1. So obviously that's just going to be 1, and I'm returning that, okay? Because now this completes, popped off the stack. But I returned a 1. Okay, where did execution stop here after the print binary? So now it has to complete dividend mod 2. Okay, 3 mod 2 is a remainder of 1, right? So I have 1 and appending the 1, which of course is the string 1, 1. Okay, and that gets returned or popped off the stack. Okay, so now here, what was returned? The string 1, 1. And I'm appending to it dividend mod 2, 6 mod 2, no remainder, 0. Okay, and of course that is going to be the string 1, 1, 0. Okay, and now it's done, popped off the stack, returns. And what is returned? Give me back here. Bad thumb. Do it down here. It returns the string 1, 1, 0. And it's going to mod, this was the first time it was called, 13 mod 2 is a remainder of 1, which of course will give me, it's going to return the string 1, 1, 0, 1. Okay, so that's the answer when it was called the first time, print line, the string 1101. Question? In this case, yes, you could probably do it quicker with a loop because every time a procedure is called, there's other information, pointers, other things I'm popping on here. However, if you get to, say, a merge sort, okay, other things like this, full decomposition, and this is the way that humans think too. When we talk about solution finding, humans use heuristics. When you think about what you do to reformulate a mathematical equation, we break it down and then analyze its elements. Okay, so really, what we're doing here mimics the way that humans solve problems too. Certain things lend themselves to recursion, other things don't. Okay, but this drives home. Hopefully, you'll never forget code segment, data segment, and stack segment. And the stack segment is used for procedure calls, method calls, things of this nature. Okay. Now next, what I did want to show you also was just a bottom-up design. And I want to show you a couple things. Well, first, what you're doing in Program Logic 1 is largely application development. Java, of course, allows you to create applets, which run in a browser in the sandbox, too, with additional security. So I'm going to show you an applet and really bottom-up design, too. Okay? But I wanted to show you how simple it is when you write applets. This, of course, is just basic HTML. And I just wanted to highlight what all it takes to get an applet on a web page, okay, here's the code. Of course, we know that when Java is compiled, from a .java file, it creates a .class file, okay? So here's the applet code, the name, and of course it's in a string. You see the open close quotes. Code base of where this is located. Dot. What is dot? Present directory, okay? So as much as everyone hates Linux or likes it, you're gonna live it. So width 400, height 300. That's all I'm doing is specifying the size that this applet is going to take. So I will have this up on cs100.com shortly. I developed this 7 years ago maybe. And one of the things I'm using is now deprecated, so it's not standard in the Java plugin. So I have to change it a little so that it runs today. But here it is. I mean, essentially, when you look at this, really, you take out all the comments, you're probably looking at 25 lines of code, okay? And really, the key thing is someone created a J-color chooser. And you can use this to allow the user to choose their colors in a lot of different ways. So real quick, compiled and run, and move this over to the right screen. Okay, so of course this again is an applet. It just opened up another JFrame in this case, but a web page. Okay, and of course you didn't see me write this code. It's not tough code, but real nice. And it's just, and here I have it set up so the mouse click is associated, the selection is associated with the text, okay, but you could do background, you could do a lot of things. And real quick, you just choose something, okay, and you can see the instantaneous change. So you could use this in many ways. On a website, you allow someone to choose their text color, their background, anything. Any web authoring tool, you could just put this in, you could use this application, let the user choose their colors. So this is based on swatches. Again, in graphics, we presented that the computer also really uses an RGB. So I can really show RGB components here. Take out the red, take out the green, or increase the red, take out the blue. Not sure why that little buggy there. It's not a real good red in that projector, is it? So blue's better. So, okay. Also, I presented, there is such a thing known as Hue Saturation and Brightness. I'm not really going to go into that. It's really was developed for the graphics industry, and it's based on conical cones, representation of color. So you could do this as well. So just a real nice color chooser. Again, all from one line of code. You know, the show dialog. That's it. So bottom-up design. Okay, let's see. Option 2.